Hello and welcome to our discussion of gravity. This is going to cover basically proportions. It's a very short little section just so that you can get through some of the problems on gravity. The idea is that gravity is a function of mass and the square of the distance between two objects. So if we have two planets attracted to each other, mass 1 times mass 2 in this equation divided by the distance between them, or specifically the square of the distance between them, is going to give us the attractional or the gravitational force. And so, depending on the mass of the planet that you have, the gravity of mass 1 will be influenced by mass 2, and mass 2 will be influenced more strongly because it's smaller by mass 1. If you were standing on a different planet, you would experience gravity a little differently. So if you're standing on Mars, for instance, let's say you weigh 200 pounds. Okay. We want to figure out how heavy you are on Mars. Well, weight is not a function, or weight is not an intrinsic to, in the way that mass is to inertia. Weight is a function of gravity. So if we weigh 200 pounds on Earth, we're going to normalize Earth's gravity to a value of 1.0. 200 times 0.377 is equal to 75 pounds. So you weigh 75 pounds on Mars, okay? And if we jump to Saturn, okay, you're going to be 200 pounds again. That's your starting weight. Okay, 200 pounds times 0.916, and you're going to be weighing a little bit less. You're going to be at 183 lbs. Okay. If you wanted to figure out, for instance, Neptune or Uranus, Jupiter, notice, is quite large because it's so massive. You're going to follow the same sort of equation. You're going to basically use the proportion of gravity as a way of modifying your weight. Okay, so that's it for proportions and calculating gravity on other planets, at least for